Hey guys, I hope everyone is having a fabulous day. All right, so let's talk about sections 4.03 and 4.04. We talked the other day, last week, about unit rate, which is how much you would pay for one or how much. Anyway, unit rate means for one. So another way or another term of saying unit rate is the term constant of proportionality. So that's what we're going to look at today. So if we have the equation y equals kx, basically that k represents the constant of proportionality. And just to be honest with you, that's a term that seems to be only used in 7th grade. As you move on to high school, 8th grade and high school, we really consider more of that number that's multiplied by x is slope or rate of change. However, this is a technical term, constant of proportionality, when you have a proportional relationship that goes through 0, 0, like we talked about the other day. If you graph it, it's a straight line, it goes through 0, 0. Then that's when you'll have a constant of proportionality. If it doesn't go through 0, 0, when you graph it, that term does not apply. That term does not apply. But let's look at a couple of things, some examples. It says for every text Ellen sends, she receives 3 texts. So the unit rate or the constant of proportionality would be 3 because when she receives one text, when she sends one text, she always receives 3. So if she sent 2 texts, she would receive 6, so on and so forth, right? So there's different ways to show this relationship. First way, or one way, is you can show it on a table. So you could call this I call it a T-chart. Some people call it an XY chart. But this clearly shows if she sends 1 text, she receives 3. If she sends 3 texts, she receives 9. However many texts she sends, she will receive 3 times as many. So the constant of proportionality or the unit rate is 1. Since y, this column, is always equal to 3 times each of these numbers, we could write it in an equation. Y equals 3x, and since the number multiplied by x is 3, that means 3 is the constant of proportionality. And we can graph this table. So 0, 0. So once again, just a reminder about proportional relationships. When they're graphs, we see 3 things are happening. Number 1, they're straight. Number 2, they go through 0, 0. And number 3, when x is 1, the y value is the unit rate. So when x is 1, y is 3, that's the unit rate. It's also the constant of proportionality because it's a proportional relationship. It goes through 0, 0. All right, you can also draw a picture, draw a diagram, but these 3 are always good, clear ways on how to express relationships between 2 different things. Now this one says, what's the constant of proportionality? So we don't see the x value of 1 on this chart, but we can figure out what it is. So remember, if we take our y equals kx, and we want to know what the constant of proportionality is, then that means to get rid of times x, if we divide both sides by x, our constant of proportionality is going to equal y divided by x. So 10 divided by 4, 20 divided by 8, and 30 divided by 12, if each of these give us the same number, then that means that, first of all, this chart does represent a proportional relationship. The other thing it tells us is what the unit rate is or what the constant of proportionality is. So 10 divided by 4 is 2.5. Divided by 4 is 2.5. So I'm pretty sure the answer is 2.5. So the equation would be y is equal to 2.5x. Let's just double check it. Is 20 divided by 8 also 2.5? Yep. And what about 30 divided by 12? It is 2.5. So that is the answer. So 2.5 is the constant of proportionality. And then the next question is, what is the unit rate? Well, these two numbers will be the same. The unit rate is also 2.5. So for one hot peppercorn, you're going to, I guess, eat 2.5 or get, I don't know. I don't know what you're doing with these peppers, but anyway, we know for one hot peppercorn, there is 2.5 cheddar corn chips. I don't know. So I think I already wrote this equation, but if y, you get y by multiplying x by 2.5, then this is our equation. All right, let's look at this one. Every female chicken lays 4 eggs. What is the constant in proportionality for the ratio of eggs to female chickens? So the order of these words matter. Since it says eggs first, you have to write 4 first. 2, how many female chickens? Well, it says for every 1 female chicken. So the constant of proportionality is just 4. So for every 1 chicken, you get 4 eggs. And let's see what the next question says. Oh, sorry. According to this graph, what is the constant of proportionality? And the second question is, what is the equation? So remember, the constant of proportionality or the unit rate is when x equals 1. Now, even though there's no dot here where x equals 1, obviously if x is 2 and y is 16, and then we have 4 and 32 and 6 and 48, we understand, or hopefully we can even see it with our own eyes, that the constant of proportionality is 8. Remember, we said that when x is 1, that number is the unit rate, and also when it's proportional, the constant of proportionality. So the equation is, so here's our y equals, what is happening to these, each of these x values? They're all being multiplied by 8. So that is our equation. All right, so here we have a couple of proportional relationships. Well, I guess the first one is, well, I guess the second one is too. All right, but anyway, it has taken 215 days to complete 700 square meters of an alligator habitat that will eventually be 1,200 meters squared. How much longer, that's a subtraction phrase, isn't it? All right, so one thing, so now I looked at Florida Virtual and it shows you one way to set this problem up, but to me it's easier if I just set up a proportion. So I would say 250 days it takes to complete 700 square meters. I want to know how many total days it takes to complete 1,200 square meters at the same rate. So here's my proportion. So on proportions, you got to keep things that are alike together, right? Days and days. And on the bottom, we have squared meters and squared meters. Okay. Now, in order to ever solve a fraction equals a fraction, you can always cross multiply. A fraction equals a fraction. So we're going to multiply 1,200 times 200, 1,200 times 250, 1,200 times 250, and that is a great big number, 258,000 equals, and then 700 times x is 700x. All right, so we're going to divide both sides by 700, and x is equal to 360, rounds up to 369 days. Now, guys, you gotta be careful because that's not the final answer, how much longer. This is the total at this rate right here. If you take this rate and you finish the entire enclosure, it would take a total of 369 days. However, we've already worked 215 days, and that's why it says how much longer would it take. So the last thing I do is subtract 369 and 215. So 369 minus 215 is, the answer is 154 more days. 154 more days. Oops. All right, anyway, my pen won't let me write it, but 154 more days. All right, the last one says, Mark stopped to watch the lion keeper as she cleaned part of the lion habitat. The keeper cleaned a 10th of the habitat in a 12th of an hour. At this rate, how long would it take the lion keeper to keep the entire area, to clean the entire area? So what is our rate? So 1/10 of the habitat divided by 1/12 divided by. So then what do we do to divide fractions? We keep it, change it, flip it. So if we multiply straight across, we get 12/10. We can divide both of those by 2. So 6/5 or 1.5 hour. How much is 1/5 of an hour? I don't know, 1/5 of 60. So what is that? 20% of 60. So it would take 1 hour and 12 minutes. 1 hour and 12 minutes. So that's how long it would take to clean the entire one area is 1 hour and 12 minutes. Okie dokie. All right, I think that's it, guys. So if you need my help on anything, let me know, and everyone have a wonderful day.